Okay, I'm going to be doing a video of 4 solving problems from section 5.5. 2 exponential problems and 2 logarithmic problems. Okay, these actually, all 4 of these problems actually come from the even numbers in your textbook. Okay, so that gives you the odd numbers for yourself to attempt. So here's our first one, 250 minus 1.87 to the x. Okay, how we solve these, of course, to solve for an exponential is to take logarithms of both sides, so you can bring the x down. But we can't do a logarithm yet because we have this on the left side with our exponential. Here's our exponential portion. This needs to be completely and utterly by itself. No other numbers around it, no negative signs around it. So the first thing we have to do here is we have to subtract 250 from both sides. This has to go away, okay, to leave us with negative 1.87 to the x equals negative 250. The next thing we have to do is get rid of this negative sign. So we're going to divide by negative 1, so that all cancels. Divide by negative 1. So we have 1.87 to the x is equal to 250. Now we're ready to take logs of both sides. Okay. Now this isn't e. You can do natural log if you want, but it doesn't save you any time unless you use common log. So we'll just use common log. The log of 1.87 to the x is equal to the log of 250. Okay. Then we use our rule from section 4. The power can come down in front. That's the whole reason why we do logs to begin with, is so we can bring the power down. And then this is just an easy solving. At this point, we divide by log of 1.87. Notice I have not done any calculator work yet, but we will now. So I'll bring up the calculator. So let me scroll this a little bit. Okay. This is a TI-83 emulator calculator. It's pretty much exactly the same thing as the 84. All the key steps will be the same. If you do not have an 83 or an 84, check this on your own and make sure you get these same answers. Okay, so we're going to do log of 250 divided by log of 1.87. That's log of 250, close the parenthesis sign, divided by log of 1.87, close the parenthesis sign. And we get 8.821. Rounding to the nearest hundredth, we'll just get 8.82. So x is equal to, what was that, 8.82? I already forgot. Yep. 8.882. And that's a solution. And of course, you can always check your work by putting 8.82 into the original problem. So the question is 250 minus 1.87 to the 8.82 approximately 0? It's close. It's 0.17. It's really, 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 really close. Don't forget, we rounded. If we used this entire answer, if 250 minus 1.87 to the 8.8210926292, it's negative 7.4 times 10 to the negative 8th, which is, of course, negative 0.0000074, which is pretty much 0. Okay, so notice how much difference, though, there is in just rounding to 2 places than to use the whole decimal that the calculator gave you. It can be off by quite a bit. Okay, now let's do the next problem. Next problem is a little bit trickier because there are x's on both sides, and you have to do some solving, and some students really, really, really struggle with this. This problem is 5 to the x plus 2 is equal to 4 to the 1 minus x. Okay, this is harder because there are x's on both sides and we need to do some solving. Well, the exponentials are by themselves on both sides, so we just go right ahead and do logs. Okay. Then these powers come down in front, the whole thing, keep them in parentheses. X plus 2 log 5 equals 1 minus x log 4. Okay. My suggestion is at this point is that because it is awkward to manipulate equations with logarithms, is go ahead and do the logs and round to like 3 places for these. Okay. So I'm not going to bring up the graphing calculator for this. I'm just going to do this off to the side. So we're actually going to do the log of 5, and we're going to round it to 3 places, and I get 0.6989, 0.699, almost 0.7. So this is 0.699 equals 1 minus x, in parentheses, log of 4. Log of 4 is about 0.602. Okay, and then we'll just solve for x. At this point, it's just a linear solving problem, so we'll distribute. So we have 0.699x plus 0.699 times 2 is 1.398 equals 0.602 minus 0.602x. Let's add the 0.602x, crosses out here, add 602x, and let's subtract negative 1.398. So this cancels. And that gives us 9, 10, 12, 1.301, I do believe. I'm going to check that. I do 1.301. So 1.301x is equal to, this one is negative 0.796 divided by 1.301, and we'll get our answer. Rounded to 2 places is negative 0.61. And there's that one. That's done. Okay. Third problem, I have some marks down here I need to get rid of. Okay. Now we get into, don't need that. Now we get into the logarithm problems. So the first logarithm problem I'm going to do is this one. Log base 5 of 8 minus 7x is equal to 3. Okay. Now solving for log problems is hard for some people because the first step really has nothing to do with the problem itself. The first step is to convert to exponential form, which means 5 to the third is equal to 8 minus 7x. And you see how easy this problem actually is. Okay, well, what's 5 to the third? 5 to the third is 125, so it's 125 equals 8 minus 7x, and I think this is pretty easy at this point. That's 117 is equal to negative 7x divided by negative 7. Let's scroll down. And then we'll get an approximate answer. Rounded to 2 places is about negative 16.71. 0.71. And you can go ahead and put that answer in and check your answer. Okay, so much easier when you convert. Now, sometimes though, you can't convert right away, and that's this next example. This next example is going to be log, this is going to be a base 10 problem, log x minus log of x plus 3 is equal to negative 1. Okay. Now in this one, we can't just simply convert because we have 2 logs on one side. You can only have 1 log before you can convert. But what we're going to use is we are going to put these two together by using our section 4 skills. We know that the difference of 2 logs is the log of the quotient. Okay? The difference of 2 logarithms is the 1 log of the quotient of the first one divided by the second one. Now we can convert. What base is this? This is base 10. We don't write that. So this is 10 to the negative 1 is equal to x over x plus 3. And then we solve. What we do is we cross multiply. We take 10 to the negative 1 times x plus 3, and this is equal to x. Okay, so this is 10 to the negative 1x plus 0.3. I should have known that without doing it on a calculator. Okay, and then we'll subtract this to the left side. And that's going to equal 0.9. Divide by 0.9. We get 1/3, I do believe. Or 0.33. If you're rounding, I guess I'll write that one. Approximately 0.33, 0.3, and we're done. I hope this helped. Thank you.